Imagine a world where your daily coffee order knows you're coming, your home anticipates your every need, and an algorithm can predict market shifts with, well, astounding accuracy. Is this science fiction, or is it the new reality of business? How much of your future career actually depends on understanding these kind of invisible forces? Get ready to level up. This deep dive is your essential guide to understanding the tech that's reshaping every single industry. We're cutting through the noise to bring you the core insights into digital transformation, focusing on the foundational skills you'll need as a BCIS 1305 student right here at the Dr. Ciampa College of Business, and honestly, beyond. This isn't just about understanding technology. It's really about applying essential and emerging business productivity information technology tools to position yourself for a bright future. Okay, before we plunge into these fascinating waters, if you're finding value in these insights, please make sure to like, subscribe, and share this deep dive with your friends and colleagues. That way, no one misses out on these insider tips.
And remember, the description has links to additional resources we think you'll find incredibly valuable. Today, we're taking a deep dive into the world of digital transformation. We're specifically drawing from Chapter 12 of Technologies for Success, computer concepts, and some supplemental resources as well. Our mission: to distill the most important concepts in cloud computing, e-commerce, artificial intelligence, and the Internet of Things. We want to show you how these pillars are not just buzzwords, but practical applications that will define your success in a digital-first business world. We'll explore the fundamentals, their real-world impact, and even some of the ethical dilemmas they present. Cloud computing, the invisible engine driving modern business. Okay, let's kick things off with cloud computing, because it's just so fundamental to how businesses operate today. Now, the official definition from ISO, the International Organization for Standardization, it can sound like a bit of a mouthful, right? All about scalable and elastic pools of resources and self-service provisioning.
Yeah, it can be a bit dense.
But at its heart, it's far simpler, isn't it? It's basically about getting computing power and storage over the internet, sort of like running electricity or water for your business instead of, building your own power plant.
Exactly. And what's truly fascinating here is that while it feels like a very modern concept, the cloud metaphor itself isn't actually new. It dates back to 1994, used by a company called General Magic to describe a universe of places mobile agents could go. Kind of abstract back then.
1994, wow.
Yeah. And then just 2 years later, in 1996, Compaq Computer Corporation, remember them. They even foresaw its potential for online consumer file storage and cloud computing-enabled applications.
Yeah.
So this wasn't just some fleeting idea. It's just that its scale and impact today are, well, unprecedented. It proves those early visions were definitely onto something. The shift from physical servers in a closet or data center to accessible on-demand resources over a network has fundamentally changed the landscape of information technology. It's a huge shift.
That historical context is really interesting. So it's been brewing for a while. To really grasp its power now and why it's so appealing to businesses, what's one characteristic of cloud computing that maybe consistently surprises business leaders, even those who think they get it?
That's a good question. I'd say it's often measured service. Businesses traditionally are used to large upfront IT investments, buying servers, building out data centers, all that capital expenditure. So the idea of truly only paying for what you actually use, sometimes down to the second of CPU time or the gigabyte of storage used, that can be revolutionary for budget flexibility.
Right, pay as you go.
Exactly. It fundamentally shifts the financial model from capital expenditure, or CapEx, to operational expenditure, OpEx. And it does it in a way many still, I think, underappreciate. Think of it like getting a utility bill for your IT. Very different mindset. Beyond that specific one, the National Institute of Standards and Technology, NIST, they identified 4 other essential characteristics that really define a true cloud system. Knowing these helps us understand its power. First, there's on-demand self-service. This means you, the user, can provision computing capabilities like server time or network storage automatically without needing human interaction from the provider.
Like a vending machine.
Precisely. Like a vending machine for IT resources. Second, broad network access. These capabilities have to be available over the network and accessible through standard mechanisms, using any device, phones, tablets, laptops, workstations. It's about ubiquitous access. Third, resource pooling. Providers pool their computing resources to serve multiple consumers, multiple tenants using a multi-tenant model. Resources like storage, processing, memory, network bandwidth are dynamically assigned and reassigned according to consumer demand. You don't usually know or control the exact location of the resources, but they're there.
Yeah.
And fourth, there's rapid elasticity. This is a big one. Capabilities can be elastically provisioned and released sometimes automatically to scale rapidly outward and inward based on demand. So to you, the consumer, the capabilities available for provisioning often appear to be unlimited, and you can appropriate them in any quantity at any time.
That rapid elasticity sounds almost too good to be true for a business during, say, a peak demand period like Black Friday.
It is incredibly powerful.
But I imagine there's maybe a flip side. Are there situations where this apparent unlimited scaling could actually become a trap for businesses if they don't manage it carefully?
Oh, absolutely. That's a very real risk. While it's fantastic for managing surges, many businesses, maybe out of old habits or just fear of being under-resourced, find themselves over-provisioning. They forget to scale down when the peak passes, or they struggle to really optimize their resource allocation.
So they end up paying for capacity they aren't using.
Exactly. It's often called cloud waste. It's a powerful tool, rapid elasticity, but like any power tool, it requires skill and attention to use efficiently and avoid those unexpected inflated costs. But taken together, these 5 characteristics, on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service, they really highlight the fundamental information technology concepts that underpin today's IT infrastructure. They offer businesses incredible agility, efficiency, and flexibility. For those of you building a career in business, understanding these characteristics helps lay the groundwork for how modern organizations manage and leverage their IT. It's foundational.
Definitely. So the cloud isn't just one thing, right? It's not a one-size-fits-all solution.
Yeah.
It offers different ways to consume services, and each way impacts how much control you have and what you're responsible for managing. This is where we get to the cloud service models, I believe.
That's right.
How do businesses choose which model is right for them? Is it about technical skill, cost, control?
It's really a mix of all those things. It depends heavily on how much control they want over their IT stack and, frankly, what they're capable of managing themselves. We primarily talk about 3 main service models: IaaS, PaaS, and SaaS. Each represents a different layer of abstraction, meaning the provider manages more as you go up the stack. So at the bottom, you have infrastructure as a service, or IaaS. This is the most basic building block. Here, the provider gives you access to fundamental computing resources, processing, storage, networks. You deploy and run your own software, including operating systems and applications on this infrastructure.
So you manage the OS, the applications, the data.
Correct. You control the operating system's storage and deployed applications. You might even have some limited control of select networking components like host firewalls. But you do not manage or control the underlying cloud infrastructure, the physical hardware, the virtualization layer. Think of it like renting a plot of land. You can build whatever house you want on it, choose the furniture, landscape it, that's your OS, your apps, your data. But the land itself, the utilities hookups, those aren't yours to manage. That's the provider's job.
Okay, that makes sense. Renting the raw infrastructure.
Exactly. Then, moving up a level, there's Platform as a Service, or PaaS. With PaaS, the provider manages the underlying infrastructure and the operating systems, middleware, and runtime environments. What you get is a platform, a development environment where you can deploy your applications, ones you created or acquired. So you might get an operating system, a programming language execution environment, a database, a web server all ready to go.
So developers love this.
Developers often love PaaS because they can focus purely on writing and running their software without worrying about managing the underlying hardware, OS patching, or infrastructure scaling. It's like renting a fully equipped workshop. You bring your ideas and materials, and you can start creating your products right away without needing to buy or maintain the tools or the building itself. We're seeing more specialized PaaS too, like iPaaS for integration flows or DPaaS for data management.
Right, and then the final one.
The final one, and the one most people interact with daily, is Software as a Service, or SaaS. Here, you simply access applications over the network, typically through a web browser or a mobile app. Think about Microsoft 365, Google Workspace, Salesforce, Dropbox. You don't manage or control any of the underlying infrastructure, not the network, servers, operating systems, storage, not even individual application capabilities, except maybe some limited user-specific configuration settings.
You just use the software.
You just use it. The provider handles all the technical heavy lifting behind the scenes. For students, this is super common. Storing assignments in Google Drive, using Microsoft 365 for projects, accessing university email, these are all prime examples of leveraging cloud-based SaaS apps. You don't manage the servers, you just benefit from the software.
That's a great breakdown of the different levels of control and responsibility. It really seems like the choice between IaaS, PaaS, and SaaS is a major strategic decision for a business. Can you maybe give us some real-world business examples where these different models truly shine? Show us how different organizations pick the right fit.
Absolutely. Let's take Amazon itself. Its massive e-commerce operation runs on Amazon Web Services, or AWS. That's a prime IS example. They need that deep control and massive scalability for their core global retail business, managing everything from the OS up.
So using their own infrastructure service.
Right. Then think about a hospital system. They often use private clouds, which we'll get to maybe running on IS or PAS, to manage sensitive electronic patient records. They need high security, control, and compliance with regulations like Type ISA. Sometimes these private clouds are managed by a third party, but they're dedicated solely to that hospital system.
Makes sense for healthcare.
And then universities like Tarleton are a great example of providing SaaS applications. We offer students access to email, collaboration tools like Microsoft Teams, maybe specific course software, all delivered as SaaS. This allows everyone, students, faculty, staff, to access necessary tools easily from anywhere without needing to install or manage complex software on their own devices. The university handles the back end. It really demonstrates the importance of applying essential business productivity tools, right? You don't necessarily need to be the IT expert managing the servers to benefit immensely from these cloud services, but understanding these models, IS, PIS, SaaS, empowers you to make smarter, more strategic business decisions about technology adoption. You'll know what questions to ask.
That's crucial, knowing the implications of choosing one over the other. Okay, so we've covered the service models, but you mentioned private clouds. That brings us to the deployment models.
Yeah.
This dictates who actually owns and manages the infrastructure and where it physically lives, right?
That's exactly right. The deployment model defines how the cloud infrastructure is provisioned, who it's for, and where it resides. There are four main models. First, the private cloud. The cloud infrastructure is provisioned for exclusive use by a single organization comprising multiple consumers, like different business units. It might be owned, managed, and operated by the organization itself, a third party, or some combination, and it could exist on or off the premises.
So more control, maybe more security.
Potentially, yes. It offers more control and dedicated resources, which can be very appealing for organizations with sensitive data, strict regulatory requirements, or specific performance needs. However, it's generally more capital-intensive to set up, and it might lack the true massive elasticity and economies of scale you get with a public cloud. Maintaining it also requires significant expertise. Then there's the public cloud. This is what most people think of when they hear cloud. The infrastructure is provisioned for open use by the general public. It might be owned, managed, and operated by a business, academic, or government organization, or some combination. It exists on the premises of the cloud provider.
AWS, Azure, Google Cloud.
Exactly. Those are the hyperscale public cloud providers. They offer vast scalability, a huge range of services, and that pay-as-you-go model we discussed. The trade-off is potentially less control and the shared resource nature, which raises security questions for some. Now, most organizations today aren't purely one or the other. They're moving towards a hybrid cloud architecture. This combines two or more distinct cloud infrastructures, private, community, or public, that remain unique entities but are bound together by standardized or proprietary technology enabling data and application portability. Think, maybe, workload portability.
Best of both worlds.
Often, yes. It's a pragmatic approach. You might keep sensitive data or legacy systems on a private cloud or even on-premises infrastructure while leveraging the public cloud for scalable web applications, development, or big data analytics. It allows businesses to balance scalability, cost-effectiveness, security, and control based on their specific needs. And finally, we're increasingly seeing multi-cloud strategies. This isn't strictly a deployment model defined by NIST in the same way, but it's a common strategy. It involves using multiple public cloud services from different providers.
Why would a company do that? Seems complex.
Several reasons. They might want to use the best-of-breed service for a specific task from different providers, or they want to avoid vendor lock-in so they aren't totally reliant on one company. It can also help with resilience. If one cloud has an outage, maybe you can fail over to another. Sometimes it's about meeting specific regional compliance needs or optimizing costs. We even see use of alternative cloud providers for specialized needs beyond the big three.
Okay, that makes sense. Spreading the risk and optimizing. So we've established cloud computing offers immense benefits: flexibility, scalability, cost savings. But it's not perfect, right? What are the big challenges or risks our listeners, especially future business leaders, really need to be aware of when adopting these powerful technologies?
You're right. It's crucial to go in with eyes open. The primary concern, the one that consistently ranks at the top for businesses evaluating the cloud, is definitely data security and privacy.
Right, handing your data over.
Exactly. When you move your operations, your customer information, your intellectual property to the cloud, you're entrusting that sensitive data to third-party providers. This inevitably raises questions about potential unauthorized access, data breaches, accidental leaks, or even government surveillance. How is the data encrypted? Who has access? What happens if the provider gets hacked? These are critical questions. Tied closely to that are compliance risks. Many industries and regions have strict regulations about data handling. Think GDPR for European data protection, or HIPAA for healthcare data in the US, or PCI DSS for credit card data. Businesses using the cloud must ensure their provider and their own use of the cloud meets these stringent requirements. Failure can result in hefty fines and reputational damage. Understanding these risks and knowing how to mitigate them through proper security configurations, contractual agreements, and auditing is a crucial part of describing the fundamentals of information technology concepts: hardware, software, security, and privacy. It's not just tech, it's risk management.
What else beyond security and compliance?
Other significant challenges include potential vendor lock-in, where it becomes technically difficult or costly to switch from one cloud provider to another. Managing the complexity and cost of dynamic cloud usage can also be tricky. That cloud waste we talked about requires diligent monitoring and optimization, and ensuring reliability and performance can sometimes be a concern, although major providers generally have very high uptime. But from a practical standpoint, looking at the upside again, the biggest takeaway for you, the listener, is that cloud computing is a massive equalizer. It makes small businesses incredibly competitive against larger established ones.
How so?
It dramatically reduces the need for huge upfront IT investment. Instead of spending millions on servers, data centers, and IT staff just to get started, a small business or startup can leverage the cloud and pay only for the resources they consume. This lowers the barrier to entry significantly. Plus, it enables that rapid scaling we discussed. A small startup can suddenly handle a massive spike in customer demand. Maybe their app goes viral without needing to frantically buy and install new hardware. They can scale up in the cloud almost instantly and then scale back down. That agility is a game changer. Furthermore, in this cloud environment, proper file management techniques become absolutely paramount. Knowing how to effectively organize, secure, share, and access your documents and data stored in online environments like Google Drive, OneDrive, or Dropbox is no longer just a nice-to-have skill. It's a foundational competency that directly impacts your personal productivity, your team's collaboration, and your organization's data integrity and security. This ties directly back to the course outcome of demonstrating proper file management techniques to manipulate electronic files and folders in local, network, and online environments. It's practical and essential.
So the cloud isn't just about IT efficiency. It's a powerful engine for strategic advantage, innovation, and competition, leveling the playing field. Okay, we've seen how the cloud provides this invisible engine. Now, let's shift gears and look at how businesses use that engine to directly reach customers and operate in this new digital age. Let's dive into the revolution of e-business and e-commerce. 2. E-business and e-commerce, the digital marketplace revolution. All right, so digital transformation means a whole new way of doing business, and e-business and e-commerce are right at the heart of it. Now, these terms, they get thrown around a lot, sometimes used interchangeably, but there's a clear distinction, isn't there? What's the core difference we need to understand between e-business and e-commerce?
That's a great place to start because the distinction is important. Simply put, e-business is the broader term. It encompasses any kind of business activity or process conducted online using internet technologies. So this includes not just selling online, but also internal processes like online supply chain management, electronic customer relationship management, ECRM, online banking, internal communication systems, employee portals, basically, a company's entire online presence and digital operations.
So much broader than just selling things.
Exactly. E-commerce, on the other hand, is a subset of e-business. It specifically refers to the buying and selling of goods and services over the internet and the transactions involved in that exchange. Think online stores, digital marketplaces, online payments. So the easy way to remember it is, all e-commerce is e-business, but not all e-business is e-commerce. Understanding this difference is vital for analyzing how companies truly operate and connect with customers in the digital age. It's not just about the online shop front.
That clarifies it perfectly. E-business is the whole online operation. E-commerce is the buying and selling part. Okay, so focusing on e-commerce specifically, we often just think of, clicking buy on a website. But I understand there are distinct types of e-commerce transactions based on who's involved. What are the key categories, and why should a business student care about these distinctions?
You're absolutely right. It's more nuanced than just shopping online. Classifying these transactions by who is selling to whom helps us understand different market dynamics, strategies, and data patterns. There are three primary types. First, business to consumer, or B2C. This is the most familiar one for most of us. It's where businesses sell products or services directly to individual consumers. Think Amazon selling you a book, Walmart.com selling groceries, Netflix selling you a subscription. This is the classic online retail model.
Right, the Amazons and Walmarts.
Second, we have consumer to consumer, or C2C. Here, individuals sell goods or services directly to other individuals. This is often facilitated by third-party online platforms. Think eBay, where you might sell old collectibles, or Facebook Marketplace, where people sell used furniture, or Etsy, where artisans sell handmade goods directly to buyers. C2C empowers individuals as sellers and creates huge marketplaces.
Like online garage sales, but way bigger.
Kinda, yeah. And finally, there's business to business, or B2B. This involves companies selling goods or services to other companies. This is actually a massive part of the economy, often larger in total value than B2C, though less visible to the average consumer. Examples include a manufacturer selling electronic components to another company that builds computers, or a software company like Salesforce providing its CRM platform to other businesses, or a platform like Alibaba connecting manufacturers with wholesalers globally.
So businesses buying from other businesses online.
Exactly. Understanding these categories, B2C, C2C, B2B, is critical for anyone in business. If you're analyzing market segments, you need to know which type you're dealing with. If you're conducting ethical business research using web-based technologies, you'll find different kinds of information and platforms for each type. And if you're analyzing sales data, perhaps using spreadsheet software, the patterns, transaction values, and customer behaviors will vary significantly between B2C, C2C, and B2B. It dictates strategy.
That makes total sense. Different playing fields. Now, it's clear that just having an online store isn't enough anymore. We hear this term omni-channel marketing a lot. It sounds a bit like a buzzword, maybe, but it seems to represent a really fundamental shift in how businesses approach the customer, doesn't it?
It absolutely is a fundamental shift, not just a buzzword. Omnichannel marketing means businesses strive to integrate all their customer touchpoints, both physical and digital, to create a single, cohesive, and seamless customer journey and brand experience.
So connecting everything.
Precisely. It's about ensuring consistency whether a customer is browsing in a physical store, shopping on the company's dedicated online storefront, like Nike.com, exploring products on a third-party online marketplace like Amazon Marketplace or eBay, seeing targeted ads on social media or websites, receiving promotional emails, or even engaging directly with the brand on social media platforms. Increasingly, social media itself is becoming a direct sales channel, with features like Instagram Shops or TikTok Shop allowing users to buy products directly within the app.
So the lines are blurring between browsing, shopping, and social interaction.
They really are. The goal of omnichannel is to meet customers wherever they happen to be and provide a unified, personalized experience across all these different channels. Maybe you browse online, add to cart, then go to the physical store to pick it up and get a follow-up email later. It should all feel connected. For students, maybe you're running a side hustle, selling crafts on Etsy or flipping items on eBay. Or perhaps you're involved in marketing for a student club. Understanding and applying these omnichannel strategies are real-world applications of using not just web-based technologies, but potentially presentation graphics software as well, as you learn to visually map out and articulate how these different channels connect and interact to form a customer journey.
The practical takeaways here seem immense for our listeners, no matter what area of business they're heading into: marketing, finance, operations, entrepreneurship. This isn't just theory. It's about applying those essential business productivity information technology tools we keep mentioning.
Exactly right. Think about major retailers adopting omni-channel strategies. They're using customer data gathered online to personalize in-store experiences or allowing online returns in physical stores, creating that seamless blend. It connects the physical and digital. In finance, the entire e-commerce ecosystem relies heavily on secure online payment systems. Ensuring compliance with standards like PCI DSS, Payment Card Industry Data Security Standard, is absolutely vital to protect sensitive customer financial data during these transactions. And look at logistics companies like UPS, FedEx, DHL have had to massively expand and innovate their operations to support the sheer volume and complexity of online deliveries generated by e-commerce. Sophisticated tracking systems, route optimization, last-mile delivery solutions, it's a huge operational challenge driven by online sales. For you, the student, the applications are direct. You'll be studying e-commerce case studies and marketing classes to understand what makes strategies successful or unsuccessful. You might find yourself creating business documents using word processing software, maybe drafting a business plan for a potential online venture, outlining your target market, value proposition, and channel strategy. Crucially, you'll be integrating various business software applications. You might use spreadsheet software to analyze sales data, track inventory, or forecast demand. You might use database software to manage customer information. You'll need to understand data analytics to make informed decisions about everything from product pricing and promotional campaigns to customer segmentation and website design. The ability to use tools like goal seeking and what-if analysis and spreadsheet software becomes incredibly valuable for solving problems and making adjustments like, what if we offer free shipping? How many more units do we need to sell to maintain profit? That's the kind of analysis needed in this environment.
It really paints a picture of a dynamic, data-driven digital marketplace. So the bottom line is this digital marketplace is vast, it's complex, and it's constantly evolving. Knowing how to navigate it effectively, understanding the different transaction types, mastering omni-channel marketing strategies, leveraging data, this is now a core competency that will define success in nearly any business role you can imagine. Okay, now let's talk about the technology that's really captured everyone's imagination, the one that feels like it's truly at the forefront of this digital transformation. Artificial intelligence. 3. Artificial intelligence, unleashing intelligent automation. All right, let's shift to the tech that's truly captured everyone's imagination lately, the one driving so much of this digital transformation. Artificial intelligence, or AI. It's way more than just robots in movies, isn't it? It's about systems that can actually learn, adapt, and make decisions in ways that, well, once seemed exclusively human.
Absolutely. AI, at its core, is about simulating aspects of human intelligence in machines. It involves using data, algorithms, and computational power to enable systems to make decisions, recognize complex patterns, solve problems, understand language, and even perceive the world around them. For students, engaging with AI introduces and develops foundational skills in applying these emerging IT tools, tools that are rapidly becoming commonplace, if not essential, in virtually every field. The core goals of AI are incredibly ambitious and multifaceted. They include things like logical reasoning, complex problem solving, representing knowledge effectively, planning sequences of actions, learning from experience or data, processing and understanding natural human language, both written and spoken, and perception, enabling machines to see and interpret sensory input like images or sounds. Essentially, AI research tries to replicate or even surpass human capabilities in these cognitive areas.
That's a huge scope. So AI isn't just one single thing, right? It's more like a broad field with several fascinating subdisciplines that actually power its capabilities, a collection of interconnected techniques.
Precisely. It's an umbrella term covering many approaches. But 3 critical subdisciplines really stand out today because of their immense impact on modern business and technology. First, there's machine learning, or ML. This is probably the aspect of AI most people have heard about, and it's the engine behind many AI applications. ML is where algorithms learn directly from data without being explicitly programmed with step-by-step instructions for every task.
Learning from data, how does that work?
Well, instead of a programmer writing exact rules, the machine is fed vast amounts of data relevant to the task, and it uses statistical techniques to identify patterns, learn correlations, and build a model that can make predictions or decisions when presented with new, unseen data. Within ML, we see different learning paradigms. There's supervised learning, where the training data is labeled with the correct answers or outcomes. Think of it like learning with flashcards. The algorithm sees an input and the corresponding correct output and learns to map inputs to outputs. This is used for tasks like classification, for example, identifying spam email, and regression, for example, predicting house prices. Then there's unsupervised learning. Here, the training data is unlabeled. The algorithm has to find hidden patterns, structures, or relationships within the data on its own without prior guidance. This is useful for tasks like clustering, for example, grouping customers with similar purchasing behavior, or dimensionality reduction, simplifying complex data. It's like being given a huge pile of photos and asked to sort them into meaningful groups without being told what the group should be. And finally, there's reinforcement learning. This is about training an agent to make a sequence of decisions in an environment to maximize some notion of cumulative reward. The agent learns through trial and error, receiving positive feedback, rewards for good actions, and negative feedback, punishments for bad ones. This is how AI systems learn to play complex games like chess or Go, or how robotic systems learn to perform tasks through experimentation. It's much like training a pet with treats and corrections.
Okay, so machine learning is about learning from data in different ways. What's the second key area?
The second critical area is natural language processing, or NLP. This field focuses on enabling computers to understand, interpret, generate, and communicate in human languages like English, Spanish, Mandarin, etc. This is incredibly powerful for bridging the gap between human communication and computer processing.
So talking to computers.
Essentially, yes, but also computers understanding written text. Specific problems NLP tackles include speech recognition, converting spoken language into text, like your voice assistant understanding commands, speech synthesis, converting text into spoken words, like a GPS giving directions, machine translation, translating text from one language to another, like Google Translate, sentiment analysis, determining the emotional tone of text, and question answering. The most impressive recent advancements here, which have really caused a stir, are the generative pre-trained transformers, or GPT models, and similar large language models, LLMs. Around 2019, these models started generating remarkably coherent and contextually relevant text. By 2023, models like GPT-4 were achieving human-level or even superhuman scores on demanding standardized exams like the bar exam for lawyers, the SAT test for college admissions, and the GRE test for graduate school. That's a huge leap in capability.
Wow, passing the bar exam, that's incredible. And the third key area?
The third area, which really underpins many of the breakthroughs in both ML and NLP, involves neural networks and deep learning. Neural networks are computing systems inspired by the structure and function of the biological brain, with interconnected nodes or neurons organized in layers. Deep learning is a specific type of machine learning that uses neural networks with many layers, hence deep between the network's input and output layers. These multiple layers allow the model to learn hierarchies of features from the raw input data. Hierarchies of features, what does that mean? Okay, imagine processing an image. The lower layers of a deep neural network might learn to detect simple features like edges and corners. The next layers might combine these to recognize slightly more complex patterns like textures or simple shapes. Higher layers might then combine those to identify parts of objects like an eye or a nose, and the final layers might integrate all this information to recognize complex objects like faces, cats, or cars. This ability to automatically learn complex representations from data is what makes deep learning so powerful.
So it builds up understanding layer by layer.
Exactly. And the sudden dramatic success of deep learning, particularly from around 2012 to 2015, wasn't really due to a brand new theoretical breakthrough. It was largely driven by two practical factors converging. First, the incredible increase in available computer power, especially the massive speed-up, like 100-fold increase gained by using graphics processing units, GPUs, originally designed for gaming, which happen to be very good at the parallel computations needed for neural networks. Second, the availability of vast amounts of training data, huge curated data sets like ImageNet, with millions of labeled images, that allowed these deep networks to be trained effectively. Power plus data was the magic combination.
That's an incredible overview of the core disciplines, machine learning, NLP, deep learning. But for someone like me, and probably many of our listeners, the real mystery remains. How does AI actually learn? Beyond the labeled or unlabeled data, what's the fundamental logic or process that allows it to think or adapt without a human explicitly programming every single possible scenario? It feels almost magical sometimes.
It definitely can feel magical, but it boils down to sophisticated computational techniques and often a lot of math. AI doesn't think in the human sense of consciousness or understanding, but it employs various methods to find patterns, make predictions, and optimize towards goals. Besides the learning models we discussed, supervised, unsupervised reinforcement, AI uses techniques like search and optimization. Many AI problems can be framed as searching through a vast space of possible solutions to find the best one, according to some criteria. Algorithms like gradient descent, used heavily in training neural networks, evolutionary computation, inspired by biological evolution, and swarm intelligence, mimicking social behaviors like ant colonies, are used to navigate these complex search spaces efficiently. Think of it like a business constantly trying to optimize a supply chain or marketing campaign. AI uses these advanced algorithms to explore possibilities and find optimal solutions much faster than a human could manually. AI also relies heavily on logic. This includes formal logic, like propositional and first-order logic, for representing knowledge and performing rigorous reasoning, but also softer forms, like fuzzy logic, which can handle imprecise concepts or degrees of truth more like human reasoning, which isn't always black and white. This is crucial for knowledge representation and decision-making. And finally, AI makes extensive use of probabilistic methods for dealing with uncertainty. Techniques like Bayesian networks allow AI systems to reason effectively even when information is incomplete or uncertain. This is vital for tasks like perception, interpreting noisy sensor data, planning, predicting future outcomes which are inherently uncertain, and learning from ambiguous data. These techniques, search, logic, probability, are combined in various ways to allow AI programs to tackle problems that suffer from what's called the combinatorial explosion. That means the number of possibilities grows exponentially, making traditional step-by-step deduction or exhaustive search impossible for large, real-world problems. AI techniques provide ways to manage this complexity and find good, if not always perfect, solutions.
Okay, so it's a combination of learning from data, searching for optimal solutions, applying logic, and handling uncertainty with probabilities. Less magic, more complex computation. Got it. And AI isn't just sitting in research labs, it's already transforming almost every sector you can imagine, creating those aha moments and driving new efficiencies everywhere. Could you give us a glimpse of some of the most impactful applications we're seeing right now across different industries?
Absolutely. The applications are incredibly diverse and are fundamentally changing how businesses operate, utilize the internet, and leverage data analytics to solve complex problems. In healthcare, AI is making huge strides. Algorithms are now reading medical imaging like X-rays, CT scans, MRIs, often with greater accuracy and speed than human radiologists, helping to detect diseases like cancer earlier and more reliably. AI is also used for drug discovery, personalized medicine recommendations, and analyzing patient data to predict health risks. The automotive industry is another hotbed. AI powers the advanced driver assistance systems in modern cars, enabling features like adaptive cruise control, lane keeping assist, automatic emergency braking, and even self-parking capabilities. It's also used for predictive maintenance, analyzing sensor data to anticipate when parts might fail.
The self-driving car potential is huge there.
It is, although full autonomy is proving very challenging. In retail, AI is ubiquitous behind the scenes. It drives those incredibly accurate product recommendation engines you see on sites like Amazon or Netflix. Customers who bought this also bought. It's used for dynamic pricing, optimizing inventory management across stores and warehouses, and even powering chatbots for customer service. And in finance, AI is transforming operations. Automated robo-advisors are providing personalized investment advice and portfolio management at lower costs. AI systems perform sophisticated market analysis, detecting complex trading patterns, assessing credit risk, and identifying fraudulent transactions much faster than humans can.
So, impacting core operations in many sectors. What about outside traditional business?
Oh, definitely. AI has achieved stunning, superhuman performance in games. IBM's Deep Blue famously beat chess world champion Garry Kasparov back in 1997. IBM Watson won the quiz show Jeopardy! In 2011. Google DeepMind's AlphaGo conquered the ancient and incredibly complex game of Go in 2016, a feat many thought was decades away. More recently, DeepMind's AlphaStar excelled in the complex real-time strategy game StarCraft II. And just recently, Google DeepMind unveiled Cima, an AI agent that can learn to play a wide variety of unseen open-world video games just by observing the screen output and responding to natural language instructions, showing progress towards more general game-playing ability.
Playing unseen games just by watching, that's mind-blowing.
It really is. Even in pure mathematics, AI is making contributions. Large language models like GPT-4, Llama, and Mistral are being used as tools by mathematicians, and specialized models like DeepMind's AlphaTensor discovered new, more efficient ways to perform fundamental computations like matrix multiplication, while AlphaGeometry recently solved complex geometry problems at a level comparable to Olympiad medalists. There are also significant military applications ranging from command and control systems, intelligence analysis, target recognition, logistics planning, cybersecurity, to autonomous vehicles like drones and robotic systems. These have been deployed in various conflicts, including operations in Iraq, Syria, Israel, and Ukraine.
And then there's the whole generative AI explosion.
Exactly. Generative AI, Gen AI, has absolutely taken off in the last couple of years. These are AI systems designed to create new content rather than just analyze existing data. They can produce remarkably realistic text like articles, emails, code Images using models like Stable Diffusion, Midjourney, Dall-E based on text prompts, audio, music, synthesized speech, and even video like Google's Veo or OpenAI's Sora from natural language descriptions. This has incredible potential for creativity, content creation, marketing, education, and much more. But it also brings challenges like the ease of creating deepfakes. We saw this play out in the 2024 Indian elections, where reports suggested around $50 million was spent on AI-generated content, including deepfakes of politicians designed to better engage specific voter segments or translate speeches into numerous local languages. That highlights both the power and the potential pitfalls.
So what does this all mean for us, really? It feels like AI is rapidly moving from performing very specialized narrow tasks to showing hints of more generalized intelligence. It's impacting everything from how we analyze data with spreadsheet software to how we interact with business productivity software applications. It really underscores that critical need for anyone building a career in business today to be able to describe the fundamentals of these information technology concepts and understand how to apply these essential and rapidly emerging IT tools. Okay, let's take that concept of intelligence and see how it's being woven into the very fabric of our physical world, beyond just screens and software. For the smart devices and the Internet of Things, IoT, bringing intelligence into our world. Right, taking AI beyond the screen, beyond the data center, we arrive at the Internet of Things, or IoT, and the explosion of smart devices that are increasingly becoming part of our daily lives, our homes, and our workplaces. It feels like it's truly a network of networks, connecting the physical and digital worlds in ways we couldn't have imagined just a decade or two ago.
That's a perfect way to put it. The Internet of Things, IoT, refers to the vast network of physical objects, things, that are embedded with sensors, software, and other technologies that allow them to connect and exchange data with other devices and systems over the Internet. These aren't just passive objects anymore. They have a digital identity and can sense, communicate, and sometimes even act upon the data they collect or receive. This directly introduces and relies on the fundamental concepts of hardware, the sensors, the devices themselves, and software, the intelligence, the connectivity protocols, working together in tandem, collecting and sharing real-time data from the physical world.
So everyday objects becoming smart.
Pretty much. Think about the common examples. In our smart homes, we have internet-connected thermostats like Nest that learn our heating and cooling preferences, smart door locks we can control remotely with our phones, smart lighting systems, and smart speakers like Amazon Alexa or Google Home that respond to voice commands to play music, answer questions, or control other devices. Then there are wearables. Things like smartwatches, Apple Watch, Fitbit, and health monitors that track our steps, heart rate, sleep patterns, maybe even blood oxygen levels or ECG readings. They collect personal health data and often sync it to our phones or the cloud. And in the industrial and business world, we have the industrial IoT, IIoT. This involves using sensors on factory machinery for predictive maintenance, detecting potential failures before they happen, tracking goods through complex supply chains using RFID tags or GPS, monitoring environmental conditions in agriculture, or optimizing energy usage in smart buildings. These systems fundamentally change how we interact with technology in our physical environment, making our spaces more responsive, efficient, informative, and sometimes automated.
That paints a really vivid picture of this interconnected world. So, bringing it back to business, how are companies specifically leveraging these interconnected IoT devices, often combined with the power of AI that we just discussed, to actually become more productive and gain that competitive edge we talked about earlier?
That's where it gets really powerful, the synergy between IoT and AI. AI in the workplace, often fueled by data from IoT devices, is manifesting in several impactful ways, transforming business operations. One major area is data analytics. IoT sensors generate enormous streams of real-time data about processes, environments, customer behavior, equipment status, you name it. AI algorithms can then analyze this massive data set far more effectively than humans, uncovering hidden patterns, predicting future trends, and helping managers make much more evidence-based decisions. This allows for sophisticated what-if analysis. What if we change this parameter in the manufacturing process, and goal-seeking? What's the optimal temperature setting to minimize energy use while maintaining comfort? Directly addressing complex problems in a business environment. This ties directly into the course learning outcomes related to using these analytical functions, often within spreadsheet software or more specialized analytics platforms.
So using the data from things to make smarter decisions.
Exactly. Another significant application is robotic process automation, or RPA. While not always strictly IoT, RPA often works in concert with systems fed by digital data, some of which might originate from IoT devices. RPA uses software bots to automate repetitive, rule-based digital tasks, things like processing invoices, updating customer records in a database, reconciling accounts, or handling routine payroll updates. By automating these mundane, often time-consuming tasks, RPA frees up human employees to focus on more complex, creative, strategic, and customer-facing work that requires human judgment and empathy. Imagine the efficiency gains when a bot handles thousands of routine transactions flawlessly.
Taking the robot out of the human, as they say.
That's a good way to put it. And then there are AI chatbots and virtual assistants, which are increasingly sophisticated. Powered by NLP and machine learning, they can handle a growing range of customer service inquiries, answer frequently asked questions, guide users through processes, and even complete transactions, offering 24/7 support and improving customer experience while reducing operational costs. We see these practical applications everywhere. AI-powered robotics on manufacturing factory floors using sensor data to optimize assembly lines and ensure quality control. Smart medical sensors continuously monitoring patients' vital signs, providing critical real-time data to doctors and nurses. Automated checkout systems in retail using computer vision and sensors to streamline the shopping experience. These aren't futuristic concepts, they are impactful applications happening now, fundamentally demonstrating the integration of business software applications, hardware, and the power of data analytics to make informed decisions and solve real-world problems.
It's fascinating how these technologies are converging. Now, to really bring this down to the individual level, we actually have a fascinating case study from Malaysia that looks specifically at how IoT-based smart home technology, or IoT SHT as they call it, is impacting users' actual quality of life. This seems like it could provide some really specific, tangible examples of how these technologies benefit people in their day-to-day existence.
Yes, this study is really insightful because it moves beyond the technical specs and asks, how does this actually change people's lives? Researchers conducted in-depth interviews with 11 experienced IoT smart home users in Malaysia to understand their motivations, uses, and the perceived impacts. What they found was quite transformative across several dimensions of quality of life. The study identified 6 main uses: real-time remote control, like adjusting the thermostat from work, surveillance, checking security cameras, sensing, getting alerts from smoke or motion detectors, home automation, lights turning on automatically, entertainment, voice-controlled music, and even family communication, though this was less common. But the impacts were categorized into 15 distinct benefits directly affecting users' quality of life, often aligning surprisingly well with needs outlined in Maslow's hierarchy. For example, improved convenience was huge. One participant, P6, loved being able to remotely access and control their smart home anytime, anywhere. Another, P10, mentioned no longer locking themselves out thanks to a smart door lock, a simple but significant daily convenience.
Yeah, I can relate to the fear of locking myself out.
Right. Another major theme was improved home security. Participant P9 highlighted how real-time video feeds and sensor alerts felt far superior and more proactive than traditional passive alarm systems, especially relevant given Malaysia reported over 14,000 break-in and theft cases in 2020. That peace of mind is invaluable. Users also reported significant time-saving benefits, particularly with automated chores like robot vacuums doing the daily cleaning, freeing up precious hours, and there was an element of fun and enjoyment, with smart speakers providing instant access to music or information.
So practical benefits, security, and even fun. What else?
The study found impacts on well-being, too. Family care was enhanced, for instance, by using smart cameras to keep an eye on infants, P8, or elderly parents. Some even felt their self-image was boosted by living in what felt like a futuristic house, with P7 jokingly comparing it to Tony Stark's home. The improved living environment was tangible. P3 used smart air purifiers to combat seasonal haze, while P5 appreciated the daily cleaning by the robot vacuum improving air quality. And health tracking was a key benefit for users with smartwatches like P2 and P5 monitoring activity levels and even blood oxygen, which P5 found vital during the COVID-19 pandemic.
Wow, health monitoring directly linked to the smart home ecosystem.
Yes, and perhaps most uniquely, some users found it fostered a sense of companionship and closeness. P1 and P5 mentioned using devices like the Amazon Echo Show for frequent video calls with family living far away, creating a feeling of shared presence and connection even when physically apart. And there were practical benefits like energy saving, with P6 reporting a 10–20% monthly reduction in their power bill by automatically turning off unused lights and appliances. Finally, home safety was significantly boosted by smart smoke and gas detectors, providing immediate alerts, P5. This research really underscores how IoT SHT, when implemented effectively, helps fulfill a wide range of human needs, from basic safety and security up through convenience, connection, and even self-actualization, demonstrating the very practical application of these information technology tools in enhancing everyday life.
What an incredible range of impacts, from saving money on electricity to feeling closer to family. It really shows how this technology, when properly implemented and adopted, can fundamentally change daily life for the better. But as always, there must be challenges, right? No technology is a silver bullet. Did the study touch on the downsides or difficulties?
That's a crucial point, and yes, the study did highlight challenges. The most prominent concerns raised by users revolved around user privacy, data security, and trust. When you bring internet-connected sensors, microphones, and cameras into your home, questions about who is collecting the data, how it's being used, and how secure it is become paramount. These are not trivial concerns and remain significant hurdles for wider adoption. This directly emphasizes the importance, for anyone studying business or technology, of understanding the fundamentals of security and privacy within information technology concepts. It's a key learning outcome, precisely because these issues are so central to modern tech. Interestingly, the study also noted that while family communication was identified as a potential use, it was actually the least utilized feature among the participants. This was partly attributed to service limitations in Malaysia at the time. For instance, Google Voice Assistant calls weren't fully functional locally.
So the potential isn't always realized due to practical limitations.
Exactly. It suggests that while the technology offers immense potential, its real-world impact also depends heavily on the maturity of the supporting ecosystem, adaptation to local contexts and regulations, and critically addressing those user concerns about privacy and security to build trust. For students, this underscores the importance of conducting ethical business research when considering the deployment of web-based technologies, understanding both the capabilities and the limitations or potential harms in a specific context.
So the takeaway here is that IoT and smart devices aren't just flashy gadgets. They're becoming deeply integrated into how we live and work. They offer tangible, significant benefits across many aspects of life, but they also raise critical questions about privacy, security, trust, and the need for context-specific solutions. This brings us very naturally to a really important broader discussion about the responsibilities that come with these powerful tools, the ethical considerations in communicating with AI, the human tech frontier. These powerful technologies, cloud, e-commerce, AI, IoT, they're transforming our world. But as we've touched on, they come with significant ethical baggage. The conversation around AI and digital transformation isn't just about innovation and efficiency. It has to be about responsibility, right?
Absolutely. It raises that fundamental question. AI and related technologies have incredible potential benefits, but they also carry potential risks, harms, and unintended consequences. It's absolutely crucial for future business professionals, for all of you listening, to be acutely aware of these ethical dimensions. It's not optional anymore. Let's unpack some of the major concerns. First, privacy and copyright are huge battlegrounds right now. Machine learning, especially deep learning, requires vast amounts of data to train effectively. This leads to serious concerns about intrusive data gathering. Think about virtual assistants like Alexa or Google Assistant constantly listening, or IoT devices collecting data about your home environment. Amazon, for instance, acknowledged recording millions of private conversations to improve its speech recognition algorithms, which understandably raised significant privacy alarms. And on the copyright side, the rise of generative AI trained on massive datasets scraped from the internet has sparked major legal battles. Authors like John Grisham, George R.R. Martin, and Jonathan Franzen are suing AI companies like OpenAI, arguing their copyrighted works were used without permission or compensation to train models like ChatGPT. How concepts like fair use apply to AI training data is a massive legal gray area currently being fought out in courts. Website owners can use robots.txt files to signal whether they allow scraping, but enforcement is tricky.
Right, the data sources are a huge issue. What else?
Second, there's the concern about dominance by tech giants. A handful of large corporations, Alphabet, Google, Amazon, Apple, Meta, Facebook, Microsoft, dominate the AI landscape. They own much of the cloud infrastructure, possess enormous data sets, and employ top AI talent. There's a real risk that this could further entrench their market power, stifle competition from smaller players, and give them disproportionate influence over the direction of AI development and deployment. Third, the power needs and environmental impacts are simply staggering and often overlooked. Training large AI models and running the data centers that power cloud computing and AI services consume prodigious amounts of electricity and water for cooling. Forecasts suggest that the electricity demand from data centers, AI, and cryptocurrencies could double by 2026, potentially reaching the equivalent annual electricity usage of an entire country like Japan.
Doubling. Wow.
Yes. This massive energy demand could seriously hinder efforts to transition away from fossil fuels, potentially delaying the closure of coal or gas power plants. We're seeing companies make unprecedented moves. Microsoft struck a deal to get power from the company reopening the 3 Mile Island nuclear plant site, and Amazon actually purchased a nuclear-powered data center in Pennsylvania. In places like Taiwan, a semiconductor manufacturing hub, power shortages have already led to the suspension of new data center approvals. Just performing a single search on a platform like ChatGPT is estimated to consume roughly 10 times the electrical energy of a standard Google search. This environmental cost is a critical, often hidden aspect of our reliance on these information technology concepts.
That energy footprint is alarming. What other ethical risks are top of mind?
Fourth, misinformation and deception. AI tools make it significantly easier and cheaper to generate highly realistic deepfakes, video or audio, and spread targeted propaganda or disinformation at scale. This raises profound concerns about online deception, erosion of trust, and the potential manipulation of public opinion, especially in sensitive areas like elections. As mentioned, the 2024 Indian election saw widespread use of AI-generated content, blurring the lines between authentic communication and sophisticated manipulation. Fifth, algorithmic bias and fairness. This is a huge one. AI systems learn from data, and if that data reflects existing societal biases, racial, gender, socioeconomic, etc., the AI will not only learn but potentially amplify those biases in its decisions. The infamous Google Photos incident in 2015, where its AI labeled images of Black individuals as gorillas, is a stark example. Another is the Compass software used in the U.S. justice system, which was found to exhibit significant racial bias in predicting recidivism rates. Machine learning fundamentally predicts the future based on patterns from the past. So if the past includes biased decisions, the AI will learn to perpetuate those biases. It makes AI inherently descriptive of past biases rather than prescriptive of fair outcomes, unless specifically designed and audited to counteract this.
So it can bake in unfairness. That's deeply concerning.
It is. Sixth, there's a lack of transparency, often called the black box problem. Many sophisticated AI systems, especially deep neural networks with millions or billions of parameters, operate in ways that are incredibly difficult, sometimes even impossible, for their own designers to fully understand or explain. How exactly did the AI arrive at that specific decision or prediction? This lack of interpretability is problematic, especially in high-stakes domains like healthcare or finance, where understanding the reasoning is crucial for trust and accountability. This has led to the growing field of explainable AI, XAI, developing techniques like Shape-It and Lime to try and shed light on these black boxes. Seventh, the risk of bad actors and weaponized AI is substantial. AI can be repurposed for malicious ends, including widespread surveillance, as seen with mass surveillance systems classifying potential enemies of the state in places like China, creating autonomous weapons systems, targeting propaganda more effectively, or enabling sophisticated cyber attacks and digital warfare.
Yep.
And lastly, the specter of technological unemployment. While economic history generally shows that technology creates more jobs than it destroys in the long run, many economists acknowledge that the speed and scope of AI's potential impact put us in somewhat uncharted territory. Studies offer varying predictions. One famous Oxford study suggested 47% of U.S. jobs were at high risk of automation, while OECD studies suggested a lower figure around 9%. What seems clearer is that AI is likely to disproportionately affect certain types of jobs, particularly routine cognitive tasks often found in middle-class roles like paralegals, accountants, or certain kinds of analysts. We're already seeing concrete examples like reports of 70% of Chinese video game illustrators losing their jobs due to generative AI image tools. There appears to be a potential shift towards jobs requiring high levels of social intelligence, creativity, and physical dexterity, particularly in care-related professions, which are currently harder to automate.
That's a sobering list of challenges. It truly underscores that understanding information technology concepts today absolutely must include understanding its societal implications, the critical importance of cybersecurity, and the deep-seated need for privacy protections. It's not just about what the technology can do, but wrestling with what it should do and mitigating the very real potential harms alongside the benefits.
It absolutely calls for that deeper reflection. It demands ongoing dialogue, thoughtful regulation, and ethical frameworks to guide development and deployment. It's not just a technical challenge, it's a societal one.
These ethical discussions, especially around bias and decision-making, naturally lead into some pretty deep philosophical questions about what intelligence even means in the first place. Alan Turing, a pioneer of computing, famously proposed his imitation game, the Turing test, where a machine tries to fool a human into thinking it's also human through conversation. But is simply imitating a human conversation truly the goal or even the right measure of artificial intelligence? Or is there maybe a bigger picture we should be looking at?
That's a fantastic philosophical question, and it gets to the heart of how we define AI's purpose. Turing himself was cautious. He originally asked, "Can machines think?" but found that question too ambiguous, too loaded with definitions of think and machine. So he proposed replacing it with a more pragmatic question based on behavior. Are there imaginable digital computers which would do well in the imitation game? Essentially, can machinery show intelligent behavior that's indistinguishable from a human's in conversation? While the Turing test provides evidence of intelligence based on this behavioral limitation, many AI researchers and philosophers argue it's flawed as a definitive test or goal. It inherently penalizes non-human forms of intelligence. Why should an AI have to pretend to be human to be considered intelligent? Many AI pioneers, like John McCarthy, who coined the term artificial intelligence, or Nils Nielsen, argue that AI is not, by definition, just a simulation of human intelligence. McCarthy defined it more broadly as the science and engineering of making intelligent machines, while Nielsen described intelligence as that quality that enables an entity to function appropriately and with foresight in its environment. Others define it more functionally as the computational part of the ability to achieve goals in the world, or simply the ability to solve hard problems.
So, focusing more on capability and goal achievement, not just mimicry.
Exactly. This functional perspective focuses on the practical outcomes and problem-solving capabilities of AI, rather than whether it perfectly mimics human thought processes or conversational quirks. This actually leads to a fascinating observation known as Moravec's paradox. Hans Moravec and others noted that, contrary to early expectations, high-level reasoning tasks that require abstract thought things humans find difficult, like playing chess or proving mathematical theorems, turned out to be relatively easy for AI to master. But low-level sensor motor skills, the instinctive tasks that humans and even animals perform effortlessly, like recognizing objects in cluttered scenes, navigating a room, or exhibiting basic common sense, have proven to be extremely difficult for AI.
That seems backward.
It does seem backwards from a human perspective. It highlights that what we find easy isn't necessarily easy for computation, and vice versa. This paradox also reflects the ongoing tension and debate within AI history between different approaches. The early symbolic AI, or good old-fashioned AI, GOAI, which focused on manipulating symbols according to logical rules, good for reasoning tasks, versus the more recent dominance of subsymbolic approaches like neural networks and deep learning, which learn patterns directly from data, better for perception tasks, but often lacking common sense. Ultimately, the question of what constitutes true intelligence, and whether current AI possesses it or is just sophisticated pattern matching, remains a deep philosophical debate with no easy answers.
Fascinating. So, given this incredibly complex landscape AI with astonishing capabilities, but also profound ethical dilemmas and philosophical questions, how do we, as humans, as students, as future business professionals, effectively interact and communicate with these AI systems?
Yeah.
How do we maximize their usefulness while mitigating the risks? What are the practical communication skills we actually need to develop?
That's a really crucial point, because for AI to be truly useful, especially in a business context, humans need to be able to communicate their needs and intentions clearly to the AI and also interpret its outputs correctly. This is becoming a vital skill, often understated but profoundly impactful in daily work. There are a few key principles. First, we need to learn to use clear, unambiguous commands and prompts. AI systems, especially current ones, lack true human understanding and common sense. They interpret instructions literally. So avoiding slang, jargon, overly complex sentences, or ambiguous phrasing is essential to prevent misinterpretation and get the desired result. This applies whether you're giving a voice command to a smart speaker, writing a prompt for a generative AI model like ChatGPT or Midjourney, or configuring parameters in an AI-powered analytics tool. Precision matters.
Be specific, be clear.
Exactly. Second, it's critical to understand the limitations of the AI system you're interacting with. AI cannot handle every request perfectly. It can make mistakes, hallucinate facts in the case of LLMs, exhibit biases, or fail to grasp nuances or context. Recognizing these boundaries prevents frustration, helps you critically evaluate the AI's output instead of blindly trusting it, and ensures you leverage AI for tasks where it genuinely excels, rather than trying to force it into roles it's not suited for. Don't expect emotional intelligence or deep understanding in the human sense. These principles apply directly to your student life and your future business applications. Think about practicing precise voice commands with smart speakers to set reminders or manage your study schedule effectively. In a business setting, managers are increasingly using AI assistants for tasks like scheduling meetings, summarizing documents, or drafting emails. This requires clear, concise instructions to work well. Customer service teams rely heavily on chatbots for answering FAQs and handling basic transactions. The effectiveness of these interactions hinges entirely on how well the chatbot understands the user's query, clear input, and how clearly it presents information, understandable output. Finance analysts might use natural language queries to interrogate large data sets using AI tools. The quality of the insights they get back is directly tied to how effectively they formulate their questions. Being able to articulate your needs to an AI system in a way it can process accurately and efficiently is rapidly becoming an essential soft skill in our increasingly digital-first world. It's about developing foundational skills and applying these essential IT tools and critically integrating various business software applications where AI is increasingly embedded.
That's a really practical take on it. It's not just about the tech, it's about our ability to communicate effectively with the tech. This definitely raises one more important question for me. As we embrace these tools, as we develop the skills to communicate with them, what responsibility do we bear, individually and collectively, in actively shaping their development and use? How do we ensure they enhance, rather than detract from, the human experience and societal well-being?
That's the million-dollar question, isn't it? And arguably the most important one. It's not just about being passive users. It's about becoming active, informed, and ethical participants in this technological evolution. It's on all of us, developers, policymakers, educators, business leaders, and everyday users, to engage in these conversations, advocate for responsible practices, demand transparency and accountability, and consciously guide this transformation towards outcomes that align with human values. It's not just a technical proficiency challenge, it's fundamentally an ethical stewardship challenge.
Ethical stewardship. I like that. Okay, so we've journeyed from the elastic infrastructure of cloud computing through the dynamic digital marketplaces of e-commerce into the complex cognitive capabilities of AI and out to the pervasive presence of IoT connecting our physical world. It's clear we're in the midst of a complete digital transformation of business and daily life. It's exciting, maybe a little intimidating sometimes. So for our listeners, the students who will be the business leaders of tomorrow, how can they truly prepare themselves to not just survive, but thrive in this rapidly changing environment? What are the absolute must-haves from everything we've discussed?
Based on everything we've covered, the key learning outcomes for you, the learner, really involve a blend of strong conceptual understanding and highly practical, hands-on application skills. First, you absolutely need to be able to describe the fundamentals of information technology concepts. This includes understanding the basics of hardware, software, networks, data, security, and privacy. These are the essential building blocks upon which everything else rests. Second, you must demonstrate proper file management techniques. In a world dominated by digital information stored locally on networks and increasingly in online cloud environments, knowing how to effectively organize, name, secure, backup, and retrieve electronic files and folders is crucial for personal productivity, team collaboration, and data governance. It sounds basic, but it's fundamental. Beyond those foundations, mastering core business productivity software is non-negotiable. This means being able to create professional business documents with word processing software, utilizing features like spelling and grammar checks, advanced formatting and layout options, tables, citations, incorporating graphics effectively, and even using mail merge for personalized mass communications. Crucially, being able to create business documents and analyze data with spreadsheet software. This goes way beyond basic sums. It means using tables, sorting and filtering data, creating insightful charts and graphics, leveraging powerful tools like pivot tables for summarizing large data sets, potentially automating tasks with macros. It means mastering statistical, financial, logical, and lookup functions and formulas to perform complex calculations. And it involves using add-ins and advanced features like goal seeking, finding the input needed to achieve a desired result, and what-if analysis, exploring the impact of changing variables, to truly solve problems and make informed adjustments or recommendations in a business environment. Developing the ability to create compelling business multimedia presentations with presentation graphics software, using templates effectively, organizing content with lists and groups, applying themes and colors consistently, incorporating clip art, pictures, tables, charts, and even video appropriately, and utilizing transitions and animation thoughtfully to enhance, not distract from, the message. Understanding different views for outlining and delivery is also key. And depending on your path, understanding how to create databases and manage data with database software, designing tables and fields, establishing relationships between tables, using indexes and keys for efficiency and integrity, creating views, formulating queries to extract specific information, designing user-friendly forms for data entry, generating informative reports, and knowing how to import and export data. But it's not just about using these tools in isolation. A key skill is learning how to integrate these business software applications effectively, perhaps embedding a spreadsheet chart into a word processing report, or linking presentation data back to a spreadsheet, or exporting database query results for further analysis in Excel. And finally, you must be able to use web-based technologies not just for browsing, but to conduct ethical business research, finding credible sources, evaluating information critically, citing properly, and understanding the ethical implications of data gathering and usage online. These aren't just abstract academic exercises listed in a syllabus. These are the practical, hands-on skills that employers are looking for. They are the tools you'll use daily to communicate, analyze, persuade, manage information, and ultimately contribute effectively and lead in this dynamic, complex, and exciting digital economy. Mastering them allows you to make those informed decisions and crucial adjustments needed in any modern business environment. Outro.
Wow, what a deep dive that was into digital transformation. Seriously packed with insights. We've journeyed all the way from the foundational, almost invisible infrastructure of cloud computing, exploring its core characteristics like elasticity and its different service and deployment models, straight into the dynamic, fast-paced world of e-business and e-commerce, revealing how transactions, customer engagement, and marketing have been fundamentally revolutionized online. Then we unpack the truly astonishing capabilities of artificial intelligence, digging into machine learning, natural language processing, those powerful generative AI models, and seeing how AI is achieving superhuman feats in some areas. We saw how the Internet of Things is weaving that intelligence into our physical world, transforming everything from our home security and energy use to how we care for our families. But just as importantly, we confronted those essential, sometimes uncomfortable ethical considerations, the challenges around privacy, algorithmic bias, the staggering environmental impact, the potential for misuse, and even questioning the very definition of intelligence itself. It's a powerful reminder that technology, however advanced, is ultimately a tool shaped by human hands and human values.
Absolutely. And remember that opening question we posed, is this future sci-fi or a new reality? I think it's crystal clear from our discussion that it's very much a present reality. Understanding these technologies, the cloud, e-commerce, AI, IoT, isn't just beneficial anymore. It's absolutely essential for navigating the modern world, personally and professionally. They're reshaping every single industry, just as we predicted, and the skills we've discussed today are really your fundamental toolkit for participating and succeeding in this new landscape.
So true. As you reflect on all these insights, please don't forget to like this deep dive if you found it valuable, subscribe for more content designed to help you navigate this tech-driven world, and share with anyone else, friends, colleagues, classmates, who needs to level up their understanding of the digital forces shaping our future. And remember, you'll find additional resources, links, and materials related to today's topics in the description below to help you continue your learning journey.
So here's a final thought to leave you with. Given the incredibly rapid pace of digital transformation we've discussed, what emerging technology, maybe one we touched on, or perhaps something else on the horizon, do you believe will have the most surprising, perhaps disruptive impact on your chosen career path in the next 5 to 10 years, and why? Take a moment to really think about that. The future of business isn't just about what you know, it's about how you apply technology ethically and effectively to make things happen. Thanks so much for listening.